Bismillahirrahmanirrahim. In this session, we will discuss variations or proportion. There are two types of proportions we usually consider: direct proportion or indirect proportion. In a direct proportion, the one is an independent variable and the other one is an independent variable. Here, x and y are two variables. Here, y is dependent on x, so with a variation in x, y will be varied. Similarly, for indirect proportion, the same phase is in inverse relationship. Here, x and y will proportional, but it is inversely. Here, increase in x will decrease in y, or similar, or vice versa. If x is decreases, then y is increases. So we will discuss these relations in exercise 23.1. The question number 1, here we have describe the variation in each of these situations using the symbols proportional. The time that the journey takes t and the speed of the train is s. So if the speed is increased, then less time will be required to complete the journey. So this is in inverse relationship. So this is speed is in the indirect proportions. The number of pages and the number of words. The number of words increases, the number of pages will increase. So these two variables are in direct proportions. The depth of water in a rectangular tank and the length of time it has been filling. If depth is more, then more time will be required to fill the tank. So this is in direct relationship. The number of buses needed to carry 2,000 people and the number of seats on a bus. So if number of buses increases, the number of seats will increase. So again, it will be in direct relationship. The time a journey takes t at a fixed speed and the distance covered. So more time will cover more distance if the speed is constant. The number of ice cream you can buy c and the amount of money you have m. So if you have more money, you can buy more ice cream. So this money and ice creams are in direct relationship. Now the question number 2, describe the variations shown in each of these tables of the values using the symbol proportional. So here we have x and y. X is 3, y is 1, x is 15, y is 5. So x is increases, y is also increases. So this is in direct relationship, direct proportions. So if x is 4, y is 28. If x is 15, y is 105. So this is again in direct proportion because x is increasing, y is increasing. Now x is 8, y is 20, x is 8, y is 10, x is 20, y is 4. Now x is increases and y is decreases. So this is in inverse relationship. The one variable is increasing, the other one is decreasing. So this is in inverse relationship or indirect proportion or inverse proportion. Now we have x 10, correspondingly y is 50, x is increases to 12, y is 60. So this is in direct proportion. Similarly, x is in decreases, y is decreases. So this is again in direct proportion. Here x is 3, y is 5, x is 15, y is 1. So this is in inverse relationship. So because the x is increases and the y is decreases. Now variations as a formula. Find a formula for each variations in exercise 20.3. So this is left as an assignment. So the question number 2, the Ohm's law states that if a voltage V is applied across a terminal of an electrical component, a voltage V is applied across a terminal of an electrical component, and if the current flowing in that component is I amperes, if the current flowing through any component, if a voltage V is applied across any electrical component and a current is flows I, then I is directly proportional to voltage. So if voltage is increased, the current is increased. So when X is equal to voltage is equal to 15, I is equal to 2.5. Find the formula for the variation. Since they are in direct relationship, so if V is increases, the current is increases. So this proportional goes with the some constant value. This proportional gives some proportional, gives some constant value. So this is I is equal to K into V. Here where K is a constant and K is equal to I upon V. So this I is 2.5 and V is equal to 15. So this is K value is 1 over 6. Now in part B, find I when V is equal to 60 volt. So I is equal to K V. V is 60 and K value is 1 over 6. So I is obtained as 10 amperes. So voltage is increases from 15 to 60. The current is also increases from 2.5 to 10 amperes. Now W meter is the wavelength of a sound waves and F hertz is the frequency of the wave. Then W is inversely proportional to 1 over F. When F is equal to 300 hertz, W is equal to 1.1 meter. Find the formula for the variations. So this W is inversely proportional to frequency. So W is equal to this proportionality, right, goes with some constant is equal to K 1 over F. So this F may be shifted to the left hand side. So this K is equal to W into F. So we have been given W wavelength is 1.1 meters and frequency is 300 hertz. So this K value is basically 33 meters hertz, meters per second. Now find W when W is equal to 660 hertz. Now its frequency is increased from 300 to 660. So the frequency is increased, so the length will decrease. So this 1 over F is 660. So W is equal to 0.05 meters. So 5 centimeter. Previously it was 1.1 meter. Now it is 0.05, means 5 centimeters. Now question number 4. The variable A and B are such that B is equal to 50 when A is equal to 20. Write down a formula when A is directly proportional to B. So A is directly proportional to B. So A is equal to K into B. Now write down a formula when A is inversely proportional to B. So A is inversely proportional to B means A is inversely proportional to B, and this proportionality goes with some constant. So this AB is equal to K. Now these two variations, calculate B when A is equal to 25 for each of the two formula you have found. So from the above part 1, A1 and A2, we can have to find the value of B when A is equal to 25. So A is equal to 25. Initially we have given 20 and 50. From this we have obtained this value of K is equal to 0.4, and from this 0.4 we have A is equal to 0.4 B. From this relationship A is equal to KB, we have initially we have found the value of k from this relation. From this relation we can find the value of k, and after getting the value of k we will substitute the value of a and find the value of b. So initially from the 20 and 50 we have obtained value of k is equal to 0.4, and from a and so this in this relationship this a is equal to the value of k is 0.4b, and from here a is given as 25, so we'll write here 25 divided by 0.4, so this b is equal to 62.5. so a is increasing, the b is increasing. So this is the first variation, which is direct variation. In case of inverse variation, the relationship would be ab is equal to k. So ab is equal to k means k is this one 1000, and from this relation from the initial values, and then place when a is equal to 25 we have b is equal to 40. So a is increases, the b is decreases here in this case. Other types of variations are maybe y square 1 over x square, y is proportional to under root x, y is equal to inversely relation to the 1 over under root x, y is equal to x cube, y is inversely relation with this x cube. So in chapter exercise 23.3 y is equal to x square and y is equal to 3 when x is equal to 6. For this relation find a formula connecting x and y. So y is equal to x square, so y is equal to by removing this proportionality we have some proportionality constant, y is equal to kx square, so y is equal to 3 and x is equal to 6. In place of x we write down 6 and this is x square, so value of k is obtained as 3 and 6 square means 36k. So k is equal to 1 over 12, so y is equal to 1 over 12 x square. Now find y when x is equal to 12. So value of y is equal to 1 over 12, and in place of x write down value of x is 12 x square, so y is equal to 12. Find x when y is equal to 48. So in place of y we have placed the value of 48 and then 1 over 12 and x. So we can obtain value of x is equal to 24. For y is equal to this we can formulas find the same way, and now y is directly proportional to the square root of x, and y is equal to 8, and when x is equal to 9. For a direct relationship we have given square root of x, so y is directly proportional to the square root of x. This is given, this is the given information. From the given information we have write down y is directly proportional to the square root of x, so this proportionality goes with this equal sign and with some proportionality constant, so y is equal to k under root x. So in place of y we have write down 8, and in place of x we have write down 9. The under root 9 is equal to 3, so this is 3k, so k is equal to 8 upon 3, so 8 upon 3 we can write down with. So in place of k we have write down this 8 upon 3. Now from this relationship when x is 5 the value of y can be obtained. So this is easy, this we can evaluate it. Similarly for x when y is equal to 4, so we can place y is equal to 4 here and enter x, and this is shifted here and 8, so this is x equal to 3 by 2, under root x equal to 3 by 2 is taking a square root on both sides, so this is 9 upon 4, so 2 completes 1 over 4, so this is x. Similarly this one can be solved. Now solve this one. Y is directly proportional to x cube and y is equal to, it's directly proportional to x cube, this information, so this is used here. Y is equal to, y is directly proportional to x cube, so this y is equal to x k x cube, so y is given 20, x is given 2. So for 2 cube, this y is equal to 20. So from this we have obtained the relationship k is equal to this, or further simplification k is equal to 5 upon 2. So we have this 5 upon 2 is here, y is equal to 5 upon 2 x cube. So x is given as 4, so we will place the value of 4 here, and y is obtained as 160. For y is equal to 450, the value of x is equal to this. So k is already 5 upon 2, so x cube is this. So from this we have obtained x is equal to 6. One simplification, so very easy. Similarly for this one, y is proportional to x square and y is equal to 9 when x is equal to 7.5. Find value of y when x is equal to 5. So we have this relation y is equal to kx square. From this we have obtained this value of k is this. From this value of k, value of y can be obtained at this x equal to 5. So x equal to 4. So y is equal to 4 for x is equal to 5. Similarly for this relationship, y is equal to is proportional to 1 over x square, and y is equal to 10 and x equal to 3. So from this we have obtained this value of k is equal to 90, and then by placing 90 here and x is equal to 12 here, so y can be obtained as 5. So for this 8 one, and this y is inversely proportional to x square, so y is equal to 4 and when x is equal to 3. So value find y when x is equal to 10. So we have this relationship, this is given, this information is given. From this we have y is equal to k. This proportionality goes with some constant 1x square. So by manipulations, x square into y is equal to a, we can write down like that. So from this k is equal to 3 and 4, 3 square and 4. So this is k is 36. So in place of this 36 can be written down, and value when x is equal to 10. So in place of this x can be write down here. So this is it. So this y is equal to 36 upon 1 over 10 square. So this is y is equal to 9 upon 25. So similarly for this 9 one, and this a car, this is very important problem. A car skids to a halt in an accident. Investigations measures the length L meters of the skid to estimate the speed. So what was the speed of the car? It has to be assessed, at which the car had been traveling before the accident. The speed is proportional to the square root of the length of the skid. This is the relationship which will be used in here. So the speed is proportional to the square root of the length of the skid. So given that a car traveling at 20 meters per second skids 25 meters, find a formula for v in terms of L. So this is v is directly proportional to the square root of length. So v is equal to k into under root L. So L is 25 meter and v is 20 meters per second. So from this we have obtained the value of k is equal to 20 upon 5. So this is k is 4. So this v is equal to k under root L, and k is 4. So v is equal to 4. Using the formula to find the speed of the car when it skids 100 meter or 100 meters skids. Part B. So this is 100. So the car speed was 40 meters per second. 7 people can paint a bridge in 15 days. How long will it take 3 people to paint the bridge? So more people will paint the bridge in less days. So number of persons and number of days are in inverse relationship. So D is equal to K into 1 over P. So days are 15s. So we will write down number of 15 days, and 7 workers or people are working. So this K is equal to 105. Now D is equal to k 1 over p, and so for this k value we have write down 105 here, and d is equal to 1 over p. So 105 and 1 over 3. So this will require 35 days. Now the person has reduced to three people to paint the bridge. So in place of days is equal to this. So 35 days it would require. In B part, the bridge was painted in T days. If bridge is painted in T days, then we can write down like this. So this so we can write down with this relationship. So number of persons, and with this much people, the paint can be the number of days required would be given by this relationship. The force F between the particles is inversely proportional to the square of the distance between them. The force is 36 newtons when the distance between the particles is r meter. Find the force when the distance between the particle is 3 r meter. So this is simple relationship. The force between the particle is inversely proportional to the square of the distance between them. So this is basically this relationship. So F is proportional to 1 over r square. The force is 36 newton when the distance between the particle is r meter. Find the force when the distance between the particle is 3 r meter. So that this relationship, so the distance has increased to 3 r. So this F is equal to k 1 over r square. F is given as 36 newton. So this is 36 newton, k upon r square. So k is equal to 36 r square. So in place of this, F is equal to k over 3 r square. So this distance has increased to 3 times. So in this, k is equal to 36 r square. So in place of this k, we can write down 36 r square. So from this we have this r square will cancel out. So 36 will divide with 9 to get 4 newton. So the newton, the force required will be, the force between the particle will be much lower because the distance has increased. So this force is decreases from 36 to 4 newton. This is very important question. The braking distance of a car is directly proportional to the square of its speed. The braking distance of a car is directly proportional to the square of its speed. Means this is the braking distance and is directly proportional to the square of its speed. When the speed is p meters per second, the braking distance is 6 meter. When the speed is increased by 300%, the speed is increased by 300%, find an expression for the speed of the car. Find an expression for the speed of the car, that is d is proportional to v square. So this is 6 meter, and this is k. This proportionality goes with k v square. So this is k, and v propose speed is p. The speed is p meters. So this p meters square. So k is equal to 6 upon p square. So this is the directly proportional constant. Proportionality constant value is 6 upon p square. Now the increase speed has increased to 300%. It was initially it was operating at p speed. Now it has increased 300%. Increase means the speed is now 4p. 1p plus 3p. 1p plus 3p. So its speed is now 4p. So in place of this speed, we can write 4p square. So this 4p square, so 6 upon p square multiplied by 4p square. In place of this speed, we will write 4p square. This is speed. In place of this speed, initially the speed was p, and that speed has increased 300 times more. So 100% speed was initially, and 300% speed increases. So its speed is now 400%. So 400 times, 4 times. So this 4p square means 16p square, and this p square cancel out, and then 16 multiplied by 6 is 96 meters. So this braking distance is now 96 meters. So initially it was 6 meter with p speed. Now it's 96 meters with 4p speed, because 3p is times increases. And part C is very important, and the percentage increase in the braking distance, it has increased to 16 times, because this is we can divide it with 6. We will get 16. So the percentage increase in the braking distance is 1500%, means 16 times increased. So initially it was 6, and now 90 meters increases. So 90 meters is basically the 15 times, that is 1500%, which is very, very high. So the speed directly affect the braking distance. So we should drive car very carefully, because high speed is more likely to have accident chances. So this is very important question. And the 15th problem, describe the variation shown in each of these tables of values. Use the symbol alpha. So y is equal to 5, x is equal to 25, y is equal to 5, and y is equal to 125. So we can see this is 1-1 relationship. So this is a yx square relationship. So this is increase 5. So this is 5 square. So this is simply 1/5 with this relation. Similarly for this, y is equal to 5, and this is 5 and 1.25. So this, we can see this is simply this relationship. And similarly for this, so y is equal to x is equal to 1, y is equal to 1. Y, if x is reduced, the y is increased. So this is in 1/x relationship. So we can see by multiplying this together we get 1, and by multiplying this together we get 1. So this k is 1. So this is y is 1/x. Similarly for this one, so for x is reduces, y is also reduces. So this is in a direct relationship. Similarly for the h1, x and y, so x is 24, y is 4, x is increase and the y is decrease. So this is k is equal to, with this multiplication and with this 2 multiplication, we are obtaining the same results. So it means this y is inversely proportional to 1/x square. So this basically, this gives the idea. If you multiply this and you get the constant, means this directly proportional. So with this two relationship we have obtained this is in this relation. So that's all for today, and we will cover next time chapter 24.